Okay, so welcome everyone to part 3, Introduction to Halogens. They are given to group 7 of the periodic table, from fluorine, most reactive, to astatine, least reactive. Okay, their structure follows simple molecular bonds with weak intermolecular forces between these. Okay, excellent. Next, appearance and color. Fluorine, pale yellow gas. Chlorine, green. It has a stinky smell. Bromine is dark red liquid. And iodine is a grey solid. Okay, so let us repeat that. Fluorine, pale yellow gas. Chlorine, green gas. Bromine, dark red liquid. Iodine, grey solid. Chlorine dissolves to make pale green solution. Bromine, orange, distinct orange. And iodine is interesting, it forms purple. Okay, and finally, iodine also forms a kind of brown solution if excess potassium iodide is present. Okay. Iodine is insoluble in water. Although iodine is insoluble in water, it is soluble if iodide ions are present. Okay, forms triiodide, which gives it its brown color. Okay, so let's explain that as we go down the group. Okay, and let's relate that to melting and boiling points. So, since there are more electrons as you go down the group, okay, we're talking about intermolecular forces here. As there are more and more electrons happening here, there's bound to be more, the strength of van der Waals forces between the molecules increases. Okay, and so electronegativity. This is the ability to attract a shared pair of electrons. Now, obviously, as you go down the group, there is more of that shielding with the same effective nuclear charge, and therefore they are less strongly attracted to the nucleus, that shared pair of electrons, and so the electronegativity decreases, with fluorine having the highest. Let's go on swiftly. Halogens as oxidizing agents. Remember, oxidizing is loss of electrons. Now, normally halogens, as you would expect, form a negative charge, 1- charge, so usually they are good at reducing agents. However, let us take a look at an example of oxidizing agents. Oh, sorry, oxidizing agents, so they are themselves reduced. Yes, that makes sense. So as you go down the group, okay, that shielding happens, and so it's less that electron, shared pair of electrons, sorry, that electron that's going to be donated to it is going to be less strongly attracted to that nucleus, and therefore will make it a weaker attraction to that nucleus. So that makes the top of the group 7 the best oxidizing agent. Okay, there we go. Let's move on. As reducing agents, so they themselves are oxidized. Now remember, oxidize is loss of electrons. So to make it a better oxidizing reducing agent, there must be more and more shells, because there is more shielding, so less attraction to the nucleus, and so that electron will be easily removed. Okay, so as you go down the group, they are better reducing agents. Displacement reaction between halogens and halide ions. The more reactive halogens will displace the more reactive halides from solutions of their ions. Okay, so remember, at the top it is most reactive, and it will certainly displace the ones below it. So chlorine is higher than bromine, and so it will become the ion itself. Chlorine is higher than iodine, and so itself will become the ion. And bromine is higher than iodine, in fact, and so it itself will be this. Now, bromine ions are orange, remember, orange. And so, yeah, it gives out that orange color because there's orange gas happening. Now, iodine is quite brown, and so, yeah, there we go, brown. And this also will result in a brown color, orange color for bromine. Remember that. So, iodine displacing chlorine will not happen because iodine is lower, and so is iodine in the case of bromine, so it will not happen. Bromine is lower than this, and so it will not happen. So chlorine is a stronger oxidizing agent. As size increases down a group, the ability of the atoms to accept electrons decreases, and hence their oxidizing power decreases. We said that. Okay, so halide ions, remember Cl- with concentrated sulfuric acid. Now, this is quite interesting. Okay, let's take a look at this example here. So the variation in reducing strength of the halides can be clearly seen in the reaction of the sodium halides with this. Okay, so here's the sulfuric acid and Na halide. It forms this strange compound with an H here and an H here. Okay, so it forms that acid here, HCl for example, and it leaves one H in front of the sulfate. Okay, so there we go. Concentrated sulfuric acid is, however, also an oxidizing agent. It can be reduced to either this, that, or that. Hydrogen sulfide, sulfur, or sulfur dioxide. There we go. All three situations with water. Balance. I'm not quite sure what this means. Cl- is not a strong reducing agent, so let us explain that. Cl- has one extra electron. Reducing agent is itself oxidized, so is itself loss of an electron. So it is not oxidized by this. Only the acid-base reaction takes place and HCl is formed. Okay. So there is no ClHSO4, it's only HCl and HSO4. White fumes of this will be seen. The fumes will turn blue litmus paper red because it's acidic. Bromine ion is a better reducing agent, and it itself will, but the sulfur in the is only reduced to 6. The acid-base reaction may also. I don't quite understand this. I don't know why. Okay, I don't understand this. I'll skip it. Test for halide ions. We're going to need silver nitrate and, where is it? Silver nitrate solution with little nitric acid. The nitric acid is going to handle the rest of those different ions that might take place. However, the important thing is that Ag plus minus, Cl minus, this. Cl is a white precipitate, Br cream, I yellow. There we go, so it handles the carbonate and hydroxide ions. Reaction of silver halides with ammonia. The three precipitates are similar in color, and thus it is not always easy to tell them apart. A further test should thus be used to distinguish between them. If dilute or concentrated ammonia is added to this, precipitate dissolves. So remember, chlorine does react with that concentrated ammonia, and that precipitate dissolves. However, the other two do not interact with it, so I'm just going to ignore that. Here. Okay, so if the dilute ammonia is added to this, but if concentrated ammonia is added, then the precipitate dissolves. So let's put that in a table. Cl- can be done with dilute or concentrated. A bromine can be done with constant ammonia. And finally, iodide has no reaction. Okay, so Reaction with water. Chlorine is slightly soluble in water and actually reacts slightly with water in a disproportionate reaction. Cl2, H2O, HCl, ClO. 0, -1, +1. This chloric acid is a mildly oxidizing agent. That's interesting. Okay, so it's important to note that chlorine is toxic. However, it is used to kill those bacteria and prevent those kinds of infections. And so chlorine dissolved in that water forms this chloric acid, which is good at killing the bacteria. Reaction with cold dilute alkali. So remember, alkali is OH minus. Now it will form some chlorine minus. Okay, fine. Just read that yourself. Okay. The acid-base reaction between adding... I don't understand that last part. Okay, bye.